That's the moral of the story.
Okay, 4-3, right triangle trigonometry. We are going to deal with right triangles. When I gave you your circle, I put a right triangle in the circle. That's how we found the points, right? So we like the right triangles in the circle, but I'm not going to think about the circle anymore. I'm going to think about that right triangle that I can move around and go anywhere with. Okay? So it is going to allow me to do much more than I was able to do before. Is it still recording? Janice? That's okay. I've learned. I have a trick, I think. But I was just talking. Cool. Okay, so right triangle trick. We're going to use this right triangle. I'm done.
It's Connor and Alex, not anyone else.
I'm done, guys. Let's focus. Okay, sine. I told you yesterday what sine was, and you didn't write it down, but now you got to write it down. Sine was y over r, correct?
Yes.
Okay. It is opposite over hypotenuse. If I put this triangle in a circle, and this is the x-axis, isn't the opposite of this angle the y? Yes?
Yeah.
If I put this triangle right here in the in the coordinate plane, and I want this angle right here, theta, isn't opposite the y value? Because up and down is y, correct? And my hypotenuse is my radius, isn't it? Okay. And I'm not going to write out opposite, adjacent, and hypotenuse. I hope you know that OPP would be opposite, correct? So sine is opposite over hypotenuse. Therefore, cosecant is what? Hypotenuse over opposite. Cosine is adjacent over hypotenuse. Adjacent means touching, correct? So adjacent would be touching the angle. Secant then is the reciprocal, hypotenuse over adjacent. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. This will allow us to use our 30, 60, 90, whatever, our 45, 90, and our quadrantals. Remember, those are those ones that make the quadrants.
Yep.
Points to make that whole circle. You only need those three things to come up with every angle on that circle that we had.
What's the adjacent side again?
Adjacent is the side that touches the angle you're talking about. So this is our central angle. So this is the adjacent. Now, if I moved, so I'm going to label these. I'll label this side A, side B, and side C. If I come up here and talk about this angle alpha, what's the opposite? B, and the adjacent is A, correct? So it's dependent on the angle you're talking about. Opposite of that angle, whatever angle you're talking about. Now the hypotenuse is always the hypotenuse, yes? Hypotenuse is across from the right angle. It is always the longest side of the triangle. What else? Am I missing anything? I don't think I'm missing anything. Okay, so I can use these three things to get any value on that unit circle, as long as I use the reference angle. Because remember we said 5 pi over 6, right? Is the reference angle is pi over 6, 7 pi over 6. The reference angle is pi over 6. Pi over 6 is 30, right? So I can use this and the fact of what quadrant it is, positive, so right, positive and negatives, to do that entire circle. And it's much easier. So if you don't know these yet, 30, 60, 90, 45, 45, 90, and the quadrantal, the points, because there's a circle, an imaginary circle here, right? Those points, unit, 1 unit, you need to get those down. You need to write them. Every time you use a 30, 60, 90, you need to write the 30, 60, 90 and write the ratios on it. Every time you use a 45, 45, write the triangle, put the ratios on it. You need to get them. Every time you use sine, cosine, tangent, write. Oh, I just put over H. A over H. Over A. Would that be easy to write on my paper so I get it in there?
Yes.
O stands for what?
Opposite.
A stands for H. Hypotenuse. How do I know what's opposite? And how do I know what's adjacent?
The opposite is the, it's okay, Riley, I know what. Like from the angle, the opposite.
Right. Opposite is across the triangle, right? And adjacent is what?
The side by the angle.
Right. It helps make the triangle, doesn't it? Or the angle. The adjacent helps. The adjacent with the hypotenuse makes the angle you're talking about every time. So, everyone have the slide? Shelby, let me know when you're good.
Good.
Everyone else good? Sadie?
No, it's okay.
You got everything?
I was listening and not writing anything down. I got like the equations, I just don't have the triangle.
Okay, we'll draw these many times.
Look at that, gosh.
No, it's still recording, guys. All I have to do is turn back on AirPlay. And it's going to shrink the screen again. And then I'm going to have to make it big again. Okay, so we need to remember the Pythagorean theorem. A squared plus b squared equals c squared. A and b doesn't matter, they're legs, right? I never solve for b. I always solve for a if I'm solving for a leg. It's just me. Does it matter? No. What is c always? Hypotenuse. C is always a hypotenuse. So you can look at it as this. Hypotenuse equals opposite squared plus adjacent squared, or a squared plus b squared equals c squared. It doesn't matter. The distance formula, Pythagorean theorem, the equation of a circle, they are all the same equation. And I'm going to tell you the distance formula, I can't ever remember that stupid thing. I do now because I teach it, but if I had to go use it on like some test, I would do Pythagorean theorem because it's just easier to think about. Because it just is. So, find the 6 trig functions for the given theta. Well, here's my triangle. Yes?
Yep.
What am I missing?
Hypotenuse.
The hypotenuse. Yes? It's this, right?
Yeah.
If this is a special Pythagorean triple, it is 3, 4, 5. It happens all the time. So if you get that in your head, you're like, ooh, 3, 4, 5. As long as 5 is the hypotenuse. If 5 is on a leg, don't get tricked because the book does that a lot. They put 5 on a leg. So how would I find this hypotenuse algebraically if I didn't know?
16 plus 9.
16 plus 9,
And then the square root of that.
and then the square root of that. So the square root of 25 is 5. Oops. Now, it is actually plus or minus 5, correct?
Yes.
But can I have a distance be negative?
No.
The hypotenuse is a distance from the central angle. It can never be negative. Write that big bold letters.
Wait,
Can my legs be negative?
Yeah.
Yes. Because which quadrant? Because my legs are X's and Y's, correct? So I can be in a negative quadrant for those. Hypotenuse is a distance, and distance can never be negative. If I was finding a leg, I need to know what quadrant I'm in to decide whether it's positive or negative. Okay? Yes, Connor?
The 2, is that supposed to be like an exponent?
Yes, that is supposed to be squared. Thank you. I need to go back and fix that. I didn't catch
Oh, I
that.
didn't even realize that was
Yeah, hopefully you just wrote it as an
I
exponent.
did, but I just
Oh, I
wanted
definitely did.
Oh, you didn't?
I did.
Oh, okay. So, again, guys, if that was a leg, I would have to know which quadrant I'm in to decide whether it's positive or negative. But since it's a hypotenuse, it's going to be 5. So now that I have these, can I find all 6 trig functions?
Yes.
Yes. So sine is what part over what part?
Opposite over hypotenuse.
Opposite over hypotenuse, so I have what over what?
4 over 3.
4 over 5.
That's what I meant to say.
If it's over hypotenuse and your hypotenuse is shorter than your numerator, Is something wrong?
Yes.
Yes, hypotenuse should always be the bigger value roaming around, always. Okay, do you want to do secant right away or do you want to use cosine? Secant.
See.
Secant? A cosecant? Cosecant of theta is what over what?
5 over 4.
H over O.
H over O, 5 over 4. Today, guys, please do that H over O, A over O. Do that for you to help you out. Cosine?
A over H.
A over H,
3 over 5.
3 over 5. Secant?
H over A. 5 over 3.
Then what?
Tangent. 3 over 4.
O over A.
Over A.
So it'd be 4
4
over
over
3.
3.
Thank you. Evan said 3 over 4. You did cotangent.
Wrong one.
You're wrong.
So cotangent?
A
Go
over O.
home.
And you split 3/4.
Now, some things I want to point out. This is sine of theta. This theta has to be there. This is a function on an angle. Got it? It's not
Yeah.
sine 3/4. No, sine of theta equals 3/4. Because we will be solving, I will tell you the sine of theta equals 3/4 and you will have to figure out theta.
Oh, fine.
So we will have to take the domain and the range and interchange them using inverse functions to find angles. Okay? So, find the 6 trig functions of 30, 60, 90, or whatever. Yeah. So this is that whole circle. This is the whole circle we're going to do, basically. Okay? Because when I do 30, I'm doing the same as 150, 210, and 330. Because they're all 30 degrees away from the x-axis, correct? When I do 45, I'm doing 45, 135, 225, 315. Because they're all how far away from the x-axis?
45.
45. When I do 60, I'm doing 60, 120, 240, 300. Because they're all what?
60 away.
They're all 60 away. We just have to decide then whether they're positive or negative depending on what quadrant they're in. Goes the same for pi over 3, pi over 6, pi over 4. Those are the same as 30, 45, and 60, correct? So, first thing I do is I make my triangles until I can see them in my head. So I have a 30, 60, 90. Okay, across from 30 is
1.
1. Across from 60,
2.
Negative, or the square root of 3.
square root of 3,
2.
2. Then I make a 45, and my 45s usually will look like 30, 60, 90s. So that's why you label it. Across from 45 is
2. Square
Square
root of 2.
square root of 2,
Square
square root of 2,
2.
2. Now, the other thing I will need is this, but I don't ask about 90 or anything, but I need this, and I need these points. What are these points?
1,
1,
0.
0.
0, 1. Negative 1, 0. 0, negative 1.
So if I know that information and I've got an exact value quiz that you'll have, it will take me like less than 30 seconds to draw those 3 things on my paper and decide and go, correct? Okay, so I want 30. Did I say this 6? I'm not going to have room for all 6, but bless you. Okay, sine of 30. Sine is what?
Opposite over hypotenuse.
Opposite of our hypotenuse. So it is
1/2.
1/2.
That's an over for a circle.
Okay, cosecant of 30.
Hypotenuse over opposite.
Okay, for today, don't just reciprocate. Please go to your triangle. Okay, hypotenuse over opposite, so I get
2 over
2. Or just 2. You can put 2 over 1, right? But just 2.
Yeah.
Cosine of 30.
Adjacent over hypotenuse.
Adjacent over hypotenuse.
Square root of 3 over 2.
Square root of 3 over 2. Secant of 30.
Hypotenuse over adjacent.
So hypotenuse would be 2 over the square root of 3.
3 over 3.
2 square root.
Right, I can't leave it like this. You guys are completely right. It is 2 square root of 3 over 3. Multiplying by the square root of 3 in the numerator and the denominator, right? So it's 2 square root of 3 over 3. Great job just immediately doing that. Hopefully you're getting kind of to the point that you can just do that in your head.
Wait, did you do it so that the square root wasn't on the bottom?
Yes, because the square root can't end up on the bottom. Okay, tangent of 30.
Opposite over adjacent.
So opposite over adjacent. 1 over the square root of 3, so square root of 3 over,
I thought it'd be square
3?
root of 3 over 1. No. Okay. Because I thought the.
no, opposite 30. Opposite of 30 is 1. Now cotangent is adjacent, correct?
Yes.
So it's adjacent over opposite, so it's going to be square root of 3 over 1, which is square root of 3. On your exact value quiz, if you leave it 2 over 1 or square root of 3 over 1, I will take off a half a point. That's not reduced, is it? Your ones, when they're in the denominator, should not be shown. So how are you going to do 60?
Same
The
way.
same way. So I'm going to give you a few minutes to do 60.
I don't know why I put the square root of 30.
30? Yep. We'll get creative with our answers. While you guys are doing that, I'm just going to talk to you real quick. You're going to get your registration. Keep working, don't stop. You're going to get your registration sheets, all of the juniors in here today. Your choice next year is calculus. If we also have another math class that is not considered a fourth year of math, but it is something to prepare you. It's called College Ready Math, and it reviews skills you've already been taught. That is an option for you. I guess if you wanted to take calculus and that, you could take both. That College Ready Math is a pass-fail math. It doesn't affect your GPA, I don't think. To me, I consider it an A or an F. And as long as you stay on your progress, because you have to progress through the program, as long as you hit your benchmarks every week, you're passing every week, so it's not difficult. But if you're looking for a fourth year of math, it's not above and beyond pre-cal. It actually goes over basic skills that colleges find that incoming freshmen don't have. And so it's a completely self-paced program on the computer. I'm here to facilitate it and answer questions. I'm not here to teach anything because it's skills you've already been taught. Am I making sense what I'm saying it is? So that's a wonderful place, like Alex, for you to go. We talked about that. I told that's the class, and we did get approved for it. So if you are interested in that, come talk to me. Some people, I had a student last year in calculus and that. She was in both because she wanted to make sure those beginning skills that sometimes we forget about doing, she had. And completely self-paced, like I said. I had one person finish the first module in 2 weeks because she tested out of everything. Okay, so it's just there, it's available. It isn't, again, it's not a fourth year of math, but it is something to keep you doing math so when you go to college, you still have been doing it. Taking a year off of math is not a very good idea. Okay, so what should you notice about all of these?
What did I notice?
Yes.
That they're just opposite of what, well, I don't know.
Yeah.
I don't know, but I noticed something.
Yeah, they're kind of similar to the last.
They're
just
similar.
Rearranged in different order.
Okay, so, but these all came,
That's not a joke.
The opposite and the adjacent switch.
okay, these came from the same triangle, yes?
Yes.
So should the same values occur?
Yes.
Yes. So you should have the square root of 3 over 2, 2 square root of 3 over 3, 1/2, 2 square root of 3, and square root of 3 over 3, if I did those right in my head right now.
Yeah.
Okay, so remember I talked about 30 and 60 are complements of each other, yes?
Mhm.
And the sine of 30 should equal the cosine of 30. Do they? Or 60?
Yeah.
Yes. Sine and cosine are co-functions of each other. So as long as the angles are complementary, the sine of one is the cosine of the other. The cosine of one is the sine of the other.
Is Kaylee Clover or Katie Rostonic there?
Yes? Oh, Kaylee Clover is.
Excuse me?
Kaylee Clover is.
Kaylee Clover is?
Yes.
Katie Rostonic?
No.
Thank you.
Maybe if you wouldn't have been irresponsible.
I know, I probably put the wrong
No,
person
not
in.
you.
No, it's because Mr. Durkin's kind of absent.
Oh,
so-
okay.
Because she didn't attend her class.
Okay. So,
I did though.
cosecant, guess what its cofunction is? Secant? Do these numbers equal each other?
Yes.
Yes. So, cosine and sine, we're good. Secant and cosecant. And then cotangent and tangent.
Wow.
Okay? They're always going to equal each other. So the sine of 17 degrees is equal to the cosine of 73 degrees. Because 17 and 73 are complementary. They equal 90. So when sometimes they'll give you really weird numbers and they'll say find the cosine of it. They'll say the sine of 23 degrees is the cosine of what? 67?
Oh, I'm busy right
Yeah,
now.
but
Okay.
I'd probably still go through it and do it.
Right. Well, you can't, but those you can't because you don't know. You don't know 23 degrees. We're going to know 60, 45, 30, and then 90, 180, and then anything that's co-functions to those, but we're not going to know 23 degrees.
Yeah. But like on
So.
the test, I'd probably still do it.
Oh, yes. I just wanted to show you. On these, you would definitely go through them and do them. Okay, so we have 45, yes?
Oh,
Yeah.
why not do 90?
It doesn't ask for 90.
Oh.
We can do 90.
No.
No, I mean, I'm sure it's a homework problem.
Yeah, but we're not.
Okay, do we need to go all the way through yours?
No.
Yeah.
Okay, you guys should be working on them already, hopefully.
I heard them done.
Yeah, are you done?
Does it matter which 45 we're using?
No, because they're both 45. And since 45 plus 45 is 90, right?
Yes.
Probably.
Some days.
Only on the weekends.
It's okay, right?
And every other Thursday.
What'd you get?
Well, the only reason I asked about 90 is because I don't know what the opposite of it is.
Oh, they're you're right. And we
Mm-hmm.
if the next slide doesn't have it on there, I will do it. Okay, so then I got 2 square root of 2, so square root of 2.
Mm-hmm.
And then the
Square root of 2
cosine
over 2.
and these are all going to match because they're
You
the
wrote
same
secant
angles.
Twice.
Yes?
You wrote secant twice. That's why I was confused up there.
Told you, I always want to mess up cosecant.
It's the same thing though.
Yes, it is the same thing. And then
One.
tangent is just 1.
Oh my god.
Okay? So 45 is really easy. The biggest thing is people forget when they reciprocate square root of 2 over 2, they forget to rationalize. Or they'll leave it 2 square root of 2 over 2. Can I leave that 2 square root of 2 over 2? No, those 2 is reduced. Okay.
That's what I was reading.
Okay. Let me see. Hopefully the next slide has quadrantals. Are we?
I'm not done yet.
Okay.
so-
Yeah, give me a minute.
That's why I stopped. Okay, my next slide doesn't have it.
Do you still want us to write down the like H over A and all
Girl.
that? With
Today I think it would be very good for you to do, just to make sure you have it. Okay?
Wait, how did you get?
Do know.
How did you get 1 on the?
Because it would be square root of 2 over the square root of 2.
Oh.
We
Yes.
just add a new slide.
Because
Yep,
the
I did.
opposite, yeah, I'm going to have to. The opposite in the
Can you just give her time?
adjacent.
Look, she was trying to.
I know, I started and then I stopped.
She wrote sin for Maddie. Sinning all the time.
Okay, are we guys good?
Yeah.
Okay, so 90 degrees was the question, yes?
Yeah.
So 90 degrees is a quadrantal angle. So we need our quadrants. So at 90 degrees, what is the point?
1. 0, 1.
0, 1.
Sorry, 0, 1.
Okay, so here's where we need to remember the x, the y definition. Here we're going to use the x, the y definition, okay? So sine is what?
O over 80.
No, but x, y definition doesn't work. It doesn't have an opposite.
Oh,
Okay, y. It's y over r, right?
Yeah.
Okay. Well, y is 1
So it'd be 1.
and r is 1, so it is 1.
Wait, R is the radius?
Yep. And if this point is 0, 1, the radius has to be 1, correct? For that circle? Okay. So secant, cosecant,
It's 1 over
1.
1. It's 1 over 1, so it's 1. Cosine,
Is X
it's x over r.
which is 0.
0
So
over
0 over 1, which is
0.
0. Secant,
1 over
Undefined.
x, which is undefined.
it's 1 over 0, so it is undefined. Again, the reciprocal of 0 is undefined. The reciprocal of undefined is
0.
0. Tangent
is Y over X.
is y over x.
1 over
0.
0, so undefined again.
Undefined. Now, we know the reciprocal of undefined is 0, so the next one better come out to be 0, right?
Yeah.
So cotangent is
X over Y.
x over y, so it's 0 over 1, so it's
0.
0. Now, what's that going to change if I said 180?
Then it would go to 0.
0.
It'd be negative.
So
My
the
points-
undefined would switch to 0 and the 0 would switch to undefined.
Yes. And then
It'd be
the
negative.
ones would switch to zeros and the zeros would switch to ones because the sign would be the y, which is 0, correct?
Yeah.
Yeah.
So the sine of 180 would be 0.
Yeah.
The cosine of 180 would be negative 1. And the tangent of 180
Would be 0.
would be 0 because it'd be 0 over negative 1. So when you do the quadrantal angles, they're actually a lot easier. You just have to remember the ones and zeros. Sadie, did your question get answered?
Kind of. The question that I have is that, like, so if we're doing, like, what we just did with the triangle thing,
Mhm.
and I asked for 90, we're going to do it this way.
No, yes, 90 there's no triangle
Okay.
because I can't make a triangle out of a vertical line.
So 90 is always going to be that.
90 is always the points. So you need to remember 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Now, I don't have to memorize those. I need to remember it's 1 unit, yes? And if it's 1 unit and I go left 1 and nothing up, that's 1, 0, correct? So you have to just think about, okay, we know how to graph, put the points there. Yes,
This is back on like the 45, 45, 90.
yes,
If it's 2 square root of 2 over 2, did you just reduce the 2 square
yes.
root of
The 2 and 2 is 1. Yep.
Okay.
Okay, let's see what else we got. Okay, this is the cofunctions we talked about. That's why I drew the arrows. Yeah, you can, what? Okay. So, cofunctions of complementary angles are equal. You need to know that. Cofunctions of complementary angles are equal. Sine, what's the cofunction? Sine, cosine. Secant, cosecant. Tangent,
Oh,
cotangent. So all this, if I have, I'm teaching, 90 minus theta, 90 minus theta just means it's complementary, correct?
Yeah.
So the sine of 90 minus theta equals the cosine of theta. So it's just saying they're complementary. So if that chart doesn't make sense to you, don't write it.
Okay. Wait, do we hit this?
Well, you need to know this right here. Yes?
So then why are we writing the chart down?
If the chart doesn't make sense to you, don't write it down. If it makes sense to you, write it down. That's decision making and note taking.
Oh, she was right too.
By the office for the salary.
Yes.